All right, here's our video for day one of sum and difference formulas. The point, well, I'll just let you look at these formulas for a second. The point of these formulas, they help us find the sine, cosine, or tangent value of an angle that's not on our unit circle. But if we can make that angle a combination of two other angles that are on the unit circle, then we can use these formulas. So, for example, in this problem down here, number 1, we're being asked to find sine of 285 degrees. Now that's not an angle on our unit circle, but we can rewrite it as the sum of two angles that are on the unit circle, 150 and 135. And then once we rewrite it like that, so this is the sine of an angle plus another angle, we come to this formula, sine of an angle plus another angle, and we have this formula where we can plug those values in, find the sine and cosine of them, and then evaluate from there. So we're going to do that in a minute, but first let's talk about some of the symbols you see in these formulas. Mainly these two right here. So we've been using theta for angles, but these two here are called alpha and beta. So this first one we'll be reading out loud and calling it alpha, and then this one we'll be calling beta. So these are Greek letters, and in fact they're the first two letters of the Greek alphabet. So if you put these together, you see how it says alphabet. So these are the first two, so alpha and beta. So down here, when I rewrote this one angle as 2, we're going to make this angle our alpha and this one our beta. So then when we apply this sine formula where we have the sum of two angles, that's what we have here, the sum of two angles, I'm going to use this alpha of 150 and this beta of 135 and plug that in here everywhere I see an alpha and a beta. So this equals sine of alpha, which in this case is 150, times cosine of beta, 135, plus cosine of the alpha, which we assigned 150, and then times sine of the beta. So now we can use our unit circle to go find those values. So if you want to pause, find your unit circle. Remember that if you're looking for the sine of an angle, it's going to be the y coordinate there. If you're looking for the cosine of an angle, it's going to be the x coordinate there. So just take a minute, pause the video if you have to, find those angles and use their x and y coordinates for their values. So sine of 150 is a half. Cosine of 135 is negative rad 2 over 2. Then we have plus cosine of 150, negative rad 3 over 2, and then sine of 135, rad 2 over 2. Now, when you are multiplying fractions, remember that you multiply across the top and bottom. So multiply the numerators, multiply the denominators. So for this first pair of fractions, that gives me negative rad 2 over 2, plus the second pair. When you're multiplying radicals, you multiply the insides together and the outsides together. So these numerators are going to give me negative radical 6 over 2 times 2, which is 4. Oh, I'm sorry. This denominator right here is 4. My bad. So multiply 2 times 2, which is 4. And now that we have two fractions with the same denominator, we can combine them into one with that denominator. So one fraction with the denominator of 4, and then I have negative rad 2 plus negative or minus rad 6. So I want you to pause the video and try the same thing with this one. Although make one change, this 2 on the bottom, I want you to change it to a 12. So sine of pi over 12. And it'd be easiest if you first convert that to its angle measure. So pi over 12 is half of, so pi over 12 is half of a sixth. So you might say, well, pi over, okay, hold on, let me retalk. Pi over 12 can be rewritten as half of pi over 6, right? So if I multiply it across the top, that's pi over 12. And an angle measure, pi over 6, is 30. So half of that is the same as 15 degrees. So pi over 12 is going to be the same as sine of 15. So pause the video, try and rewrite 15 as the sum or difference. So two other angles on the unit circle where you're adding them together or subtracting them. Now, if this is 15, that's a really small number. You're going to be subtracting. So find two angles on your unit circle that subtract to 15. Then you will use this formula, sine of two angles subtracted, plug them in for your alpha and your beta, and evaluate, and then unpause the video and check with my work. All right, here's my work here. 15 can be rewritten as 60 minus 45. That makes 60 my alpha and 45 my beta. So I'm going to plug 60 in for the alphas here and 45 in for the betas. So I've got that in this step. Then I find the values of them. Sines are y values, cosines are x values. And then I multiply the numerators and the denominators and then combine everything into one fraction at the end. Okay, these next two problems use the cosine formulas. So I'll work through number 3 and then ask you to pause the video to try number 4. And while I'm thinking about it on number 4, change pi over 2 to pi over 12 again. So for cosine 285, I'm going to rewrite 285 as cosine of 150 plus 135. So my 150 is theta, my 150 is alpha, my 135 is beta. So this first formula is the one that I'm going to be using to rewrite my cosine. So it's going to be cosine alpha times cosine beta. So cosine 150 times cosine of 135 minus sine of each of the angles. So minus sine 150 times sine 135. So if you need to pause the video, go find those x coordinates for the cosines, y coordinates for the sines, and then come back and compare yours to what I'm going to write. So cosine of 150 is the x coordinate there, or negative rad 3 over 2, times the x coordinate of 135, which is negative rad 2 over 2, then minus the y value or sine at 150, which is a half, times the y value or sine of 135, which is rad 2 over 2. Now we do the same thing, multiply numerators, denominators. This is a negative times a negative, which is positive, and then the insides are 3 times 2, which is 6. Also, those insides are called radicands. That's their official word. The denominators make 4. Then the second pair across the top and bottom, rad 2 over 4, combine into one fraction with the common denominator. And I have rad 6 minus rad 2. You pause the video and do number 4, remembering what we said in the last problem about pi over 12 being equal to 15 degrees. All right, take a moment, pause, and come back. All right, so cosine 15, again, is the same as cosine of 60 minus 45. So this will be our alpha and our beta. So we're going to be using the subtraction cosine formula, the difference formula here for cosine. So it'd be the cosines of the angles plus the sines of the angles. And I'll show you my work here for that. So cosine 60 times cosine 45 plus sine 60 times sine 45. Multiply numerators, denominators, and then combine into one fraction with the common denominator of 4. All right, for number 5, we're going to get into the tan formulas. So tan of 285, I went ahead and rewrote that as the sum of 150 plus 135. So here's the sum formula for tan. Tan of alpha plus tan beta over 1 minus tan alpha times tan beta. So I'm just going to set that up here. Tan alpha, which is 150, plus tan beta, which is 135, over 1 minus tan alpha times tan beta. So take a moment and just go find the tangent values at those angles. They're the boxed ones on your unit circle. I'm going to fill those in here. So for my numerator, tan 150, I have negative rad 3 over 3 plus tan 135, which is a negative 1, over 1 minus tan of 150, which again, negative rad 3 over 3, times tan 135, which is negative 1. Right, in both the numerator and denominator, we need to find a common denominator in combined terms. So what I'm going to want to do in a moment is a keep, change, flip situation, but I can't until I have one fraction on top and one fraction on the bottom. So I'm going to start by rewriting these ones as a number with a denominator of 3. So that means multiplying it top and bottom by 3. So my next step is going to look like this. This right here becomes negative 3 over 3, and I'm combining it with this fraction into 1. So my denominator is 3, and then I combine my numerators. Negative rad 3 minus 3. Then in the denominator, we have several things going on here. I'm going to start by changing this to a plus plus because negative times negative is positive. So I have 1 minus, and then rad 3 over 3 times 1 is just rad 3 over 3. So just like above, I need to make this one another value that has a common denominator of 3. So I'm going to multiply it by 3 over 3, and that becomes just 3 over 3. So I have 3 over 3 minus rad 3 over 3. Combining that into one fraction gives me 3 minus rad 3. All right, so now that I have a fraction over a fraction, I'm going to do keep, change, flip. I'm actually going to come down here because I need some more space to work. So I have this. I'm going to keep the top fraction the same, change to multiplication, and flip the bottom fraction. So this was a keep, change, flip. So now that I'm multiplying, these will cancel. And multiplying across the top. So when those cancel, they leave me 1. So I have negative rad 3 minus 3 over 3 minus rad 3. Now we don't leave fractions with radicals in the denominator, so we're going to need to rationalize this by multiplying by the conjugate. And I'm going to have to start the second video with that process. So we're going to pause right here, and then you'll need to start watching the second video to finish out this problem.